Hey, welcome back. Short break, and we're moving to our next speaker, Khaled Souf. So, Khaled is a developer consultant here in Montreal, Canada. I know him very well because we're co-organizing the Software Crafters meetup here in Canada, in Montreal, Canada. Uh, Khaled always talk about DDD, crafting software, clean code, XP, DevOps practices. It's always a lot of fun to hear from him. And he talked to me about how we applied TCR, so test, commit, and revert, on actual code base, like on an actual project, and it was a legacy project. And he told me that it yielded to very, very great results. Like the technique really well applied to this. And I was curious to hear more about that because I heard about the technique, but I never applied it concretely, or I think I tried it on a refactoring exercise, but I never tried it for real. So this is the moment where Raled is gonna share all of his experience on what went well, what didn't went well, and what can you get from his experience to maybe apply this way of approaching code on your own legacy code base. So without further ado, Khaled, you're up.
Okay, thank you. So, before getting to there, I'm going to talk about a game that I love and I've been playing for many times. So it's called Skyrim. I know that many, if you have gamers here in attendance, they already played that. It's really a game that you have full opportunities. You have a big world. You can have many. You can make many choices. It's always 100 hours of playing. So before continuing to talking about Skyrim and TCR, I'm going to introduce myself. Like said, Nicolas, I'm a consultant. I'm also co-organizing of Software Crafters and also Socrates. You can check more in my website. So let's get to a bit of context. So this is simply a reminder. So what is the legacy code? The first thing that you will get when you check that in internet is a code without test by Michael Feathers. So Michael Feathers, if you don't know who he is, he's the one that wrote the book about dealing with legacy code. So it's called Working Effectively with Legacy Code. So this is the definition that Michael Feathers have, but we have so many other definitions that you can check. One of the definitions that I like a lot is simply this one. So when you are dealing with legacy code, actually, when you try to modify something, when you try to touch something, you're always sweating and you don't know if it's going to work or not. So it's always complicated to do with that. Why? Because you have lost knowledge. You don't know maybe how it works. And something else also, when you try to modify that code base, you actually don't know if that modification gonna have the expected result or not. So one thing that I need you to focus on when I'm talking about that is that the legacy code is hard to understand because we can get some lost knowledge because also sometimes the code is so much complicated. It didn't age it well, so it's gonna be complicated. It's hard to test. Why? Because in most cases, we have some kind of guideline for architecture, for how it should be structured about the design. But at some point, that knowledge is lost. So somebody else gonna change that. And then there is another person that's gonna change that after a few years. At some point, you don't understand how actually your code is structured. These two problems, they're gonna give you another one that what is really hard is how to change. You can't change anything. You can add a new feature. It's really complicated to do it. So how do we make the change easy, because that's the thing. When you are dealing with legacy code, usually you try to change something. So how do we do it? So let me give you, let's say, a context about that. Yeah, I'm gonna talk about Limbo dance actually before talking about TCR, because this is how TCR was born. So Kent Beck, when he was working for Facebook, he have seen that Facebook managed to have from 700 developers to move to 5,000 developers. So he was asking himself about how we do from moving to small developers team to bigger one. How do we scale actually? What is the best approach about that? He tried several ideas, and at some point he found about this thing, what we call Limbo actually. It's in the same name as the dance, and also almost the same principle that I'm going to talk about it. It's a scaling software collaboration. So you have three principles. One is, we know that everybody is working on the same code base. So we need to be careful about that, not to cause problem to that. So how do we do that? We do it by only propagating tiny changes. So how is it related to Limbo? Actually, we lower the amount of code that's gonna commit. So in this case, we're gonna have so many commits, so many pushes to Git, if you are talking about Git, and we go as low as possible. So that's the context about TCR. And from there, he sketched some kind of diagram that we're gonna see after that. But the first question that he has in mind, can I use TDD actually to do it? Can I use TDD in really small steps to push it to the repository? And I'm gonna be working maybe with 500 or maybe 5,000 people in the same repository, in the same code base. So he managed to he didn't manage it actually to sketch, because I'm going back to Skyrim. The thing that you need to know that with TDD, that's okay to use TDD, but at some point he said, what can I do to go back in time? So that's why I'm going back to Skyrim. A thing that I usually do is, when I start playing, at some point when I'm almost finished the game, I go back and restart the game from there, because I learned so many things in doing that. You can say that the first attempt that when I'm playing this game is experimenting. So the idea is reverting, going back sometimes can be really helpful. Sometimes you're gonna find that in legacy. When I'm talking about legacy, I think Michael Feathers have been talking about that, and he call it scratch refactoring. So you do something experimental and then you go back. So the idea is always try to go back, and that's okay to ditch everything that you've done at some point. So going back to Kent Beck, he took these two diagrams. If we go back to TDD, TDD actually has two phases. One that we all, let's say, green. So we do that when we get to that when you are fixing tests, or maybe also when we are cleaning the code. So we stay in that state green. So when we are cleaning the code, I'm talking actually about the refactoring phase in TDD. And we have a red phase when the test is broken. So when do we get that? When we are adding a test, in most cases. And when he was trying to get TDD to fit to the Limbo scaling, let's say, collaboration, he actually managed to get this diagram. He didn't name it yet, but in that diagram, he has only all green. So he only stay at the step, the green. So how he do that? When he adding test, he always adding tests that pass. So when I'm talking about adding tests, it's not only adding tests, it's adding tests and just enough code to pass. And then from there, you're gonna go refactoring and make it better passing. So in the same time, he was thinking how to make the hard change easier. So this is what we call test and commit. Actually, we didn't talk about the revert phase. Why that? Because he was not the one that invented that. Actually, he was the one that invented the T and C, and then Edmond Stormy and Lars Barringer and all Jonason, they took that and they tried to create a symmetry in the case that your test fail, what we do. And Ken Beck after that have documented that. So how actually TCR works? So first of all, you write a test and with just enough code to pass, you run the test. If it passes, you commit, so you push it. And if it doesn't work, you revert it. So I've added some rule here that I call the hidden rule. It's highly recommended to cheat, but we are cheating only for the production code, not for the test. We will not push a test that actually do an assert true is true. So because it doesn't mean anything, but we can fake how the production code gonna pass that test. So we're gonna give an example. I took Java as an example, but we can take any other language. It's gonna be okay. So first thing that we write our test. Here I take, if you know the example, I take the kata, the fizzbuzz kata. So the first thing is when I give a number, they're gonna return me the number. If it is multiple of 3, they're gonna give me fizz. If it is multiple of 5, it's gonna give me buzz. And if it is multiple of 15, it's gonna give me fizz buzz as a result. So right here, we write the test. We write the production code just enough to the test to make the test pass, and it passes. So what happens when it passes? Usually, I use some kind of script, so it can, when it passes, it directly do the next action. What is commit actually. So another example, I give it 3. It should give me fizz, and I just added enough code to pass, but actually it failed. Why? Because the capital letter right here, I forgot to do it. So it failed, and what happens? It reverted. So all this code, the test and this one, we're gonna go back to the state that we have before. This is how actually TCR works. So the thing about it is you get no red steps, so you can't run your test if you are not sure that it's gonna pass. And also, you're gonna do so many tiny commits. Why is that? Because your first thing is make the test pass, and you will not take the risk. You will try to do it as fast as possible. So it's gonna be with less steps than it actually you do usually. Because if you take one, let's say, false step, or you mess something, you're gonna revert everything. So you're gonna take step by step, so you are sure that everything is working well. So how do you actually using in a real used code base? So I'm gonna give you some kind of context that we've been using it. So we got less than 1 month to do our stuff, more than 100 bugs to fix with different priorities. on 3 deployed applications. Actually, one was Java, and the 2 other applications, they were in JavaScript. We are 2 developers, and also it's our first time to deal with that code base. No one knows how it actually works. So the first thing that people, when we told them that we're going to use TCR for dealing with all these bugs, they said you're crazy. Yeah, we are actually, because we are trying something new and we don't have too much time to do it. But actually we tried because we took the time to do it, and we don't regret it at all. So first of all, we tried the classic TCR that you've seen before. So we managed to discover something that actually we needed a red face. Why? Because every time we have a bug, we need to fix that bug. We need to see at some point that when we run a test, it's gonna give us the error that we need to fix. Because if we don't have that, we don't know if that piece of code is the one that should be fixed or not. And also the other thing is, because we are on a legacy system and we are fixing bugs, we are not creating a new feature, we have almost no production code to produce, because it always was some small fixes sometimes. And even if it is big fix, it's going to be really not so big as you think, because you're only modifying an existing code. We are not creating a new code. So that's the limit of the classic TCR. So what we did actually, so we used some kind of techniques that is a variant of TCR, what is called red or revert, green or revert. So how it works, we write only the test, we run the test. If it passed, revert, because we need to be that the test was red, so we can see that we are in that piece of code that need to be fixed. So if it is in red, so we commit, and usually in my case, these 3 steps, I iterating them until also I get the best message I can get from the test about the error. And from there, so we have some kind of checkpoint right here. When we finish the 3rd step, we write enough code to pass, or we fix the code to pass. If it pass, we commit, else we go back. Because if we don't, sometimes if we don't go back, we don't remember anymore what we actually modified. So it's really a good thing that to go back. So this is actually the technique that we've been using. But let me be clear about a thing. After we've been using this in a project, one of the guys that created TCR, they created some kind of thing some kind of state that they call pending. So what they actually do is all the 3 phases that you've seen here, they don't commit, but they consider this one is a pending state. And from there, it's going to be like the classic TCR. So what we learned, actually, we learned that we didn't need the build server at all. We were 2 people, yeah, it's not too much, but why we don't need that? Because every time we try to push something, we have some kind of script that's going to run all the tests before pushing, and also before committing. So we are sure when we are pushing, we're sure that everything is working. And also something else, I know that you have some kind of asking about if somebody push or commit a code before how it works. So actually, before running the test, the script, they're gonna get all the modification that was in the server. So usually, if I'm talking about Git, it's about pulling modification, resolving conflict, and then running our tests. So the other thing that was really pleasant thing is the code is actually integrated immediately. So we will not have something big about managing conflict or maybe somebody reviewing the code, because everything is really pushed in tiny changes. And we are sure that these tiny changes, they will not broke something. The third thing that we discovered is revert phase is really frustrating. It's really frustrating, but it's like, let's say, it's like when you do some kind of mistake and then somebody slaps you or something like that. So when you do that, it's gonna always tell you, hey, maybe you did do more code that it should be. Maybe you are overthinking about that. So that's why I think the revert phase is really important, and that's the thing that's gonna push you and is gonna, let's say, restrict you to really small steps. And that's really something that is really interesting. So, yeah, but the thing is, you are sweating a lot when you run your tests right now. So before, when you are modifying the test in legacy code, when I'm was talking about dealing with legacy code, is kind of really complicated. But now, every time you run a test, you're sweating a lot. But at some point, you will not. Let's say you will not sweat a lot because you're gonna do only tiny changes. So in worst case, it's gonna be reverted. So that's okay. Yeah. So the takeaway about this talk is you need to force yourself to take small steps, because when you do that, you're gonna have less merging problem, less problems at all. And like I said, the reverse phase is frustrating, but that phase is really the most crucial and important about that. So thank you for attending. I know it's a small, let's say, talk, but I've done it this way because I will, let's say, I was thinking more about your question, because I can't expose everything and I don't know how the people they're gonna respond to that. So thank you for everything. Hello?
Yeah, thank you very much. That was great. I was talking with people in the chat at the same time. So we had Nicolas Moreau who shared Xavier. So you didn't, I think you didn't say his name, but your partner on this project was Xavier Détang, right?
Yeah, right. I think he has done also talk about TCR last year. But yeah, my partner in crime was Xavier. We've been working a lot about these things, and also because we have almost the same mindset. We always try new things. So that's why when I was talking about, are we crazy? Yes, we are crazy, but we are two that are crazy. So that's fine. We always take risks so we can learn something from there.
Yeah, that's nice. So yeah, he built this tool that you use to automate that red or revert, green or revert.
Yeah. So usually when I go back to what Kent Beck was talking about, he's always talking about when he was using the Limbo scaling, he is talking about abusing Git. So in our case, we have two scripts, actually. We created two scripts, the red script and the green script.
Mm.
Or let's say it was one script with the two phases. So when we run, we specify in what phase we are. we are in the red phase. And then from there, he took all the action that you've seen. So almost everything was automated. And then when we pass to the green phase, we run the script with the option to say, hey, we are in green phase. So we do the action that I already stated. So nothing was manually. Almost everything was automated. The only thing that we didn't like it, but we didn't know how to do it, is actually managing the message of the commit in Git. That was really complicated, because when you are in the red phase or in the green phase, you keep almost the same message. So you're going to have many tiny commits with almost the same message. The only thing that we've been thinking at that time, we were not sure if you're going to do it or not, is maybe amending the commit if you are staying in the same phase. But we didn't do it actually.
Yeah, that's interesting. We have a couple of questions.
Go ahead.
The first one is, so with this TCR process, you don't confirm that the thing, like you don't have a failed unit test to confirm that the test failed for a good reason. And so you run the risk of having a false positive unit test. And the question is, how do you handle that situation?
Yeah, that's the thing also that we've been thinking with Xavier when we are working on that. So that's why we choose actually to create another process that is red refactor or green refactor. But at some point when I check it, the creator of TCR after that, what they really recommend is, let's say you create a fictional red phase. So how it works. So when you create your test, you add some kind of tag or something that specify that is really pending. It's not finished. So that test, it will not be committed, and you can run it as much as possible, but it will stay in as something that is not committed. So you add that tag, and then when you run your script, let's say the script that is going to check if it is the TCR script, you're going to run it only on those that are not pending. So your test is pending, so it will not be run, and it will not be committed. After that, when you are sure about your test and you start to create your production code to make it pass, you let's say you run the TCR script. The only thing that is really complicated is when you remove that tag, you need to remove it at your first attempt to create a production code. So the thing is, because I've seen people cheating about that. So how they do actually, they create the test and they run it as much as possible in pending. And then when you create the production code, they put the production code is pending. That's the thing that you should never do. What you need to do is, I'm pending only the test. And when I'm finished with my test, I go to the production code and I create just enough code to make my test pass. But if I have a revert thing, so when I run that way, my test is going to be reverted. So you need really to be careful when you add your production code. I hope I responded.
Yeah, no, it's a tricky part, and yeah, I think there are some solutions. I think also it's a technique that needs to be practiced, and people will likely run into specific cases, and we need to find
the thing also I didn't specify is in most cases some people recommend that the people they are using TCR, they have a prior experience with TDD. Let me be frank with you. I didn't try it with somebody that didn't have TDD. Xavier and I, we were using TDD for several years. So I don't know how it works if you manage to, if somebody who completely new to TDD, how it's going to work.
Yeah, might be interesting, but on actual code, it might be intense, but it has value. People are mentioning that it's a question, but not really a question. But Jim, for example, says that TCR helps with the sunk cost fallacy. So it prevents you from spending too much time debugging code. Like we're all familiar with you spend 3 days to debug code that only took 3 hours to write, and what a waste. And forcing you to be into, okay, I will revert and start over in an intense mode, it saves you from spending too much time, wasting too much time into that, because you are forced to find other ways. And it's a good thing to practice deleting your code, reverting, going back, trying something again, even though we don't really like that. It's like a trial and error, just like you were mentioning Skyrim, but we can mention other kind of games. So you see that kind of games where you need to die and try again. It's that kind of approach. So Kent Beck mentioned that. Thank you, Jim, for saying it. We have a few other questions.
Just something that I need to specify that I didn't talk about in TCR, but I remember it right now. The thing about TCR, I think Emily Bash before was talking about approval testing. Mm-hmm. And also, if I think the similarities with characterization testing also in the book of Michael Feathers, the thing is, when you run your test, let's say in the approach that we've done, we got some flows also. The one problem that I've been seeing is sometimes your test is red, but maybe even when you fix the bug, you are not sure that let's say that bug that you fixed, it actually fixed it in the best way. So you need some kind of, we were thinking about that, me and Xavier, about that. Maybe we need some kind of mutation testing after that to check that we are really touched let's say we are really covered the pieces code that need to be covered. Okay, go ahead. Sorry.
No, that's. I was thinking about what you said. Mutation, introducing mutation to verify. It's indeed something you need to do. So yeah, sorry. The next question was, how long does it take to run your test? And did you run all the tests every time you run this script?
Yeah. So actually, we had two scripts. One that we are using to debug one bug in particular, and one when we try to push it, because we were using Git. So the first one is really about the process about the bug in particular for maybe a small class or small portion of code in particular. So it's really focusing. But after that, when we try to push, we rerun all the tests. So we can be sure that we didn't introduce regression elsewhere. Okay, so sorry, I try to recap that. So you run a part of your test, and then at the end, frequently you run all of the test suite. Yeah, the thing is why we did use that because actually at some point we have so much tests, so the feedback loop is become heavier and heavier. So that's why to accelerate the process, we've been doing that. Yeah, I think it's a good practice. I do that also, and I think it was underlying question, like when you have your test suite that takes, I don't know, minutes probably to run, then it's hindering your progress, and you need to take a different approach. But you also need to verify like the whole test suite frequently, because if you don't, then you realize late that you have broken something else. Yeah. Next question, did you use automatic tools to do revert on test failure? So you already mentioned that, but can you recap what were you using exactly? Was it the script from Xavier that you were using? It was actually the script from Xavier, so it was a shell script actually. Okay, so the thing that has been shared in the Slack earlier, this is what they were using to do what they described.
And finally, so that was a question from me, based on the discussion in the chat. I'm wondering, because you were two developers, so you were working in pair together on this code base, trying to fix bugs, and so you are committing on master extreme CI, as you said. That's great. I'm wondering if you're working, for example, people are maybe working with other teammates, like a team of 5 developers, 4 developers, maybe. These days, probably remotely. In this case, in this situation, how do you advise doing that? Because people won't likely change overnight and make everyone commit on master directly. So how would you do that?
Yeah, let's say, I will say it depends also, actually, in the type of project, because the thing is, if you are in an open source project, you need at some point a review, let's say a pull review, something like that. So you are working in another branch. This is when I'm talking about open source project. But when we are a team, a small team, or maybe a team of 5, or maybe even more than 5, the best thing to do is, let's say you remove completely the review in the process. You do a review maybe one time every week with all the people, doing some more programming. So you can recheck all the global design and all the stuff. And the other one, they're gonna, let's say they're gonna work in pairs in TCR. So if I'm going back to what Ken Beck was actually talking about, the Limbo scaling collaboration, one of the things that I've been saying before, I'm going back to that, is just a moment. Sorry about that. So the thing is, you have actually 2 rules. One is, when you are modifying something, you have to be sure that you will not bother anyone that is working on the same code base. So usually what they did is something that is called, before making the change, you try to get how to make the change without bothering others. That's the first rule. So how we do that, you synchronize with the others, because you're gonna maybe touch the same file, the same thing, and you try to do it tiny by tiny, so you will not impact the others. This is what actually Ken Beck recommended it. But I'm sorry, I can't tell you what is really the best solution to do it, because I didn't manage to try it in a big scale team.
Well, but that gives me food for thought, and maybe try a few things at work. We have been experimenting with mob programming, remote mob programming. And yeah, we learned a couple of things from that, but it was really, really good for some practices. And so if I try to recap, you will have a mob session with like all the engineers every week or every 2 weeks. They meet together and they review some code all together. And then the rest of the time you would advocate for doing like pairs that will be trying this.
Definitely pairs is really the best thing that you can do when you are using this technique, because when you are working with somebody else, it's gonna give you more discipline than when you are working alone.
Well, that's really good. We don't have any more questions. Yeah, the remaining question, actually, we answered it earlier. So thank you very much, Khaled, for your experience, for sharing all of that. I hope you all enjoyed that. If you have more questions, don't hesitate to ask Khaled directly on Twitter. So we shared his Twitter handle.